Hi everyone. Today we're going to follow up on what we talked about yesterday. So yesterday we focused on the interior angles in a polygon. Today we're talking about exterior angles, but really the concept is sort of similar. It's actually a lot easier. So I think our notes today are going to be really, really short and hopefully pretty simple too. So what do I mean when I say an exterior angle? An exterior angle is the angle created when one side of a polygon is extended. So if I take any side of this polygon and extend in this direction, or extend really any way that line goes, this is what we're considering to be an exterior angle. So I could do that at every single vertex. I could do an exterior angle here, I could do an exterior angle here, I could do one there, and then my last one would be here. Okay, so those are what I mean by the exterior angles. Okay, and so, well, yesterday we talked about the interior angles. We talked about these angles in here and how every shape has a different sum. So in a triangle, they add up to 180. In a quadrilateral, they add up to 360. And we figured out a formula for calculating that. Exterior angles are actually a lot simpler. Exterior angles always, no matter what shape they are, always add up to 360. Okay, I'll give you a second to write that down. But no matter what shape you're talking about, if you were to draw all those exterior angles in, like I did a minute ago, they would always add up to 360 degrees. Okay, so let's try this example. In this example, I've given you a quadrilateral. All right, so I've got four sides here. And I want you to find angle 3 and angle 4. Now, you'll notice that angle 3 is an interior angle, and angle 4 is an exterior angle. We've done questions like this with triangles lots of times, where I give you 2 of the angles and ask you to find the third. This time, I'm giving you 3 of the angles and asking you to find the fourth. But because this is a quadrilateral, I know that these interior angles are going to add up to 360. And if you weren't sure about that, you could do the 4 minus 2 times 180. That's what we talked about yesterday. And so that'd really be 2 times 180, which is 360. Okay, but you should know, because we spent all that time on quadrilaterals last week, that in a quadrilateral, the angles always add up to 360. So what I would do here is add together 61 plus 102 plus, don't forget this one here, that's a 90. And let's see, that's going to be 51, 253. So those are the angles that are already there. And then I would do 360 minus 253. And I believe I get 107 degrees. Okay, so that's angle 3. Angle 3 is 107 degrees. Let me get rid of this. Okay. Now, I have to think about angle 4. Now, I know we just talked about the exterior angles always adding up to 360. That's not going to help me a whole lot here. That would be if I drew in an exterior angle at all of these corners, which is not what I have here, which is not what I'm dealing with. But what I do know, get rid of those real quick, is angles 3 and 4 make a straight line. Okay, I've got 180 degrees right here in this straight line, and I just figured out that that's 107. So to get that angle 4, I would just do 180 minus 107, and I would get 73 degrees. And there's your angle 4. Okay? Hopefully you're looking at that and thinking, gosh, I could have done that without even learning the lesson today, because that's a pretty simple one. Okay, 2 more examples for you. Find the measure of one exterior angle in a regular decagon. So think back to what we did yesterday. When we had to find one angle in a regular figure, and remember, regular is important because that means they're all the same, we first had to start by finding the sum. And yesterday we did that with n minus 2 times 180. and then we divide to get each individual angle. That's the same thing we're going to do today, except the sum part is much easier because we just learned that the sum is always 360 degrees. Okay, so I don't have to do any math to find out what the total would be. All I have to do is take that sum and figure out if I had 360 degrees and it's a decagon, that means I'm going to have 10 interior angles, which also means I'm going to have 10 exterior angles. So in a decagon, you have 10 sides. So all I really have to do here is 360 divided by 10, and I get that each one of those angles would be 36 degrees. So again, just like what we did yesterday when we found the measure of one single angle, except that the sum part is already done for me. The sum is always 360. It doesn't matter what shape you're talking about, as long as it's exterior angles. Okay, so looking at number 3, find the value of B in the figure below. You'll notice that all of these are exterior angles, and these are all of the exterior angles for the whole figure. What is it, a hexagon? It's a hexagon. However, this is an irregular hexagon, so they're not all the same. But I do know that they would all add up to 360. So I could write my equation as 33b. Let's see, gosh, I might need some more space here. So I would write 33b plus 16b plus 10b plus 28b plus 15b and plus 18b. So I added up all 6 angles going around, and I should have 6 because it's a hexagon. And because they're exterior angles, I know they're always going to add up to 360. Okay? So now it's just a matter of counting up how many b's I have there total. Let's see. Total I would have 120b. So when I put all of this together, I get 120b equals 360. Divide by 120, divide by 120, and I get that b is equal to 3. Now luckily in this question, that's all it asked us for, was find the value of b. I could have also asked you to go back and find the measure of each one of those angles, which would have been easy. You would have just had to plug the 3 in for everything, but it would have been tedious. So glad we're done. It's just b equals 3. Okay, this next part, you have actually seen this before, so I'm going to buzz through this really quickly. When you have an exterior angle in a triangle, recall that the exterior angle is always the sum of the remote interior angles. So here's what that's really saying, is that this exterior angle out here is always going to be equal to the 2 angles on the inside that are not touching it. So not this angle, but these 2, and that's what I mean by remote. Okay, remote means far away, not touching. So if I add up angles 1 and 2, it's going to equal angle 4. Okay, that's what this theorem is saying, is that if I want the measure of angle 4, I can add 1 and 2 together. Not 3 because it's right next to it. But add 1 and 2 together and it's going to equal 4. That only works, by the way, in triangles. And actually, I think this last example, I think we did this exact example the last time when we covered this topic. So I'm going to scrap it. Don't worry about it. There are a couple of these in your homework assignment, but what I really want you to grasp is the sum of 360 with the exterior angles in a polygon. So homework for tonight is a lesson master packet covering 5, 7, 6, 7, and 7, 9. Let me just jot those down. You'll have the rest of the hour today to work on it. It is due tomorrow. And this is sort of a review of what we did yesterday and then this new stuff today. Okay, so we are gearing up for a test later this week. Just make sure you get this done for tomorrow, and we'll make sure we spend plenty of time going over it.